So the next one is testing at different levels. So there might be different types of bugs in your design. So these need to be analyzed at different levels. One can be block level and the other one can be at the boundaries of each blocks. By block level I mean to say, let's say I have a simple adder, a simple ALU. Did it do the addition of two numbers correctly or not? This can be done in a block level, like it can be written in a single module and it can be done. And whether the communication between two sender and receiver is happening consistently or not, this can also be done in a block, single block, where there is no necessity to write multiple modules or multiple blocks. That can be done in a single block. So this is straightforward, it is not much complex and it can be done in simple way. But the real challenges comes when it need to be done at a blocks, it need to be done at a boundary between blocks. Let's say I have a block b1 and I have a block b2. Here the actual challenge comes, because for a given protocol, let's say P, first designer builds a bus driver with one view of specification, while the second one builds a receiver with slight different view. When you join these two things, there might be some discrepancies happen, or there might be some inconsistent might occur. Your job is to correct these, rectify these disputed areas or inconsistent areas and make them correct. So verification plan contains the description of what features need to be exercised in my design. Like let's say this plan could be of directed and random testing. This is one strategy, and assertion based verification is one strongest strategy, where you write certain properties, convert them into system verilog assertions and try to simulate them and observe the behavior. And hardware software co-verification, emulation, formal proofs, writing certain formal proofs and proving them, that is one strongest method, and using of certain verification IPs. In our course we will be encountering all these steps at certain stages, verifying this using directed or random testing, and all these things will be encountering at some part of later. So as I said, as I previously mentioned about test bench, it has certain functionality. Let's say we are having test bench, it should do certain requirements for our design. So the steps here follows like this. Initially we generate stimulus. Let's say we generate some signal kind of thing and apply this stimulus to DUT, design under test, and capture the response. Whatever the design under test is giving, just capture that response and check for the correctness. Initially we have, let's say, specification. We check whether it is doing as intended or not. Measure the progress against verification goals. Now we have to measure whether it is up to the mark, like the verification goal is achieved or not. This thing need to be verified at the end. This is basically the test bench functionality. Let's say we have design, and on the other hand we'll have test bench. This is design and this is test bench. Initially it generates some stimulus and this is applied to the design, and design might, based on this stimulus, it generates certain response. We'll verify the correctness based on the response from the design. It's as simple as that.